Welcome to Tennis with Jameson and Alex. Dynamics plays an important part in our daily lives. We will be looking specifically at impacts and coefficients of restitution in the game of tennis. We will be solving for the coefficient of restitution of a tennis ball in a tennis court and looking at the impact that occurs when they connect.
Alright, how do we solve an impact problem? The first thing is to find the coefficient of restitution. Now this equation happens when you have two things that impact each other and you want to find how they will bounce off each other. Now you take V separation over V approach, and this is modeled by VA2 plus or minus VB2 over VA1 plus or minus VB1. So as we can see, generally, if we have two balls coming into each other, they impact and bounce off, right? So we want to measure VB2 over VA2 in only the line of impact. And the line of impact is perpendicular to the point of contact. So the two balls contact right here, and this is the parallel component, and the y-axis is perpendicular to that, and that's where the impact forces rest. We measure coefficient of restitution by how they bounce off each other. If they bounce away from each other and going opposite directions, then relatively, we're trying to maximize their velocity, so we add them. If they end up going in the same direction, then we subtract. Now, on the approach, we model this the same way. If they come in towards each other in opposite directions, then we also add them together. If they're going in the same direction, but one's faster than the other, then we subtract. Now, in our situation, the velocity of the ground is zero, both initially and after impact, because the earth doesn't really move with a small bounce of the tennis ball. So we can measure the velocity of the ball after impact and before impact and take the ratio to find the coefficient of restitution between the tennis ball that we used and the ground. Now, take it away, Alex.
When dealing with impacts, you also want to recognize that you can use your conservation of momentum equations and make sure you have your proper diagrams. What we did to solve for the coefficient of restitution was we took a tennis ball, and we dropped it on the ground, and we dropped it from 1 meter, and we saw that it bounced up to 0.56 meters. And just simply using your energy equations, you can solve for mgh being the velocity at the ground. So then we would get a velocity of A at the beginning would be square root 2g times 1 meter, and your velocity at the end would be square root 2g times square root of 0.56 meters, which would give us 1 times square root 2g for VA1 and 0.78 or 748 square root 2g for VA2. And plugging that into our coefficient of restitution equation, in this case, since B is the earth, the change in the velocity is going to be negligible because it's so much more massive than a tennis ball. So we can just make those zeros. So we can see that our coefficient of restitution is just going to be VA2 over VA1, which is going to give us 0.748.
Okay, so a situation we could see in real life is the ball coming in at some angle, going to hit the ground, and it's starting at some velocity A. And it would bounce off the ground and bounce off at another angle with a velocity A2, right? And to solve this, we would use equations, coefficient of restitution, and also conservation of momentum in the y direction.
Okay, so the first thing we would want to do is conservation of momentum in the y direction. And from that, we could solve for VB being approximately 0 because of the difference in mass of the earth and a tennis ball. So once we've solved for VB being approximately 0, we would want to go to our coefficient of restitution in the y direction. Using this equation, we could solve for VAY final, and then using conservation of momentum in the x direction, we would be able to solve for VAX final. That concludes this episode of Tennis with Jameson and Alex. Alexa, play DaBaby.
Yeah.